So this is a review for the first three sections in geometry. The first section was about points, lines, and planes. Primarily, we were interested in how you can label points, lines, and planes. For example, this is a point, point O. It has 0 dimensions, does not have a length or a width. Once you stick two of these together, now we have 1 dimension, length. And depending on if the line continues going forever in both directions, it could be a line. Or if we have one endpoint heading in one direction, it could be a ray, like this. And if we have 2 endpoints, we're looking at a line segment. We label all of those a little bit differently. If we're talking about a 2-dimensional flat surface, now we're talking about a plane. And those are labeled either with a single letter like this, notice there's not a point there, or by any 3 points on the plane that are not on the same line. So there's lots of different ways to name some of these lines and segments. Here, line AB, we had to pay close attention to what's above the letters. For example, that's the symbol for a line segment, and this one is the symbol for line, so they don't match up. So this one would have worked, this one would have worked, this one would have worked, those other ones, not so much. Remember that L here is not actually a point on the line, it's just the name of the line, or an alternate name. That's how you know, because there's not a point there. So if something is collinear, that means it's multiple points on the same line. Things that are non-collinear then are on different lines. 2 planes will always intersect in exactly 1 line. Here, that intersection is this line. You could call it a couple of different things, BD, BC, DB, DC, among others. Alternate names for planes. So here we're looking at plane T. This one doesn't really have one, because the only 3 points here are all in the same line. So that was something of a trick question. Opposite rays. This would be something like UT and UV. They have to share the same endpoint and go forever in one direction, completely 180 degrees away from each other, to be called opposite rays. Line segments on line H, there's 2 of them here. We could call that AB or BA. Remember that H is not actually a point, it's just the name of the line. Common endpoint for 2 rays, here it's just point S. Which points are collinear? Well, E, D, and B would be collinear in the same way that A and B would be collinear. What's another name for plane R? So this one is possible to rename. We could call this plane ABE, for example, or ABD. We could not call it plane EDB, because they're all on the same line. Here we have a 3-dimensional cube, and where do 2 lines intersect? That is exactly at 1 point, at point B. Here we have a line intersecting with a plane, so like a pencil stabbing through a sheet of paper. They also intersect at exactly 1 point, and again, it's point B. If things are coplanar, that means they exist on the same plane. So L, N, J, M, and K all exist on this same plane. There's a couple others, Q and P, that exist on plane S, but not on plane R. If things are non-coplanar, that means that when you consider point E in all of the possible planes that it exists upon, you're looking for a point that's not on any of those. So it was over here at point C. And we're back to the beginning there. So the next section was about measuring segments. And we started off with just a number line. And we're looking at distances. And when we cross 0, remember that absolute value, or distance from 0, is always positive. Distance will never be negative. So if we're looking at distance between H and K, we could take the largest number minus the smallest number. This becomes addition, and we get 5. You can also break it up into smaller chunks and add them together. That's what we're doing in problems like this. There's a little bit of algebra work here, but the premise is that if we take this left part, mn, as 2.5x, and we add that to this right part, which is x, we're going to get the entire thing, 5x minus 3. This goes back to algebra, just some solving equation skills. We would combine like terms. we would move the numbers over here and move the variables over there. And if we divide by 1.5, we might get 2 for x. Sometimes they will ask you, what does x equal? Sometimes they will more likely ask you, what is one of these 3 lengths? And you have to plug it back in. NR is over here. So you just plug in a 2 and your answer is 2. If it had asked you MN though, you would have had to plug it in somewhere else. So watch out for that. Then there's this idea of midpoints. In midpoints, it's a similar concept where you're adding 2 parts to equal a whole, but the difference is those 2 parts are always going to be exactly equal. For example, they tell us that B is the midpoint of AC. And since they tell us 1/2 of this is 12, the other half has to be 12, because that's how midpoints work. B is exactly in the middle, it splits it in 2. So this whole distance is 24. They also tell us that C over here is in the middle of AD, which means that this distance has to be 24. And that's how we could add them together to get 48. When it comes to expressions and how we look at either length or segments and whether they are equal or congruent, it's important to recognize that here, if we say AB with no line above it, we're talking about the length of that segment, and it might be equal to the length of CD. If we wanted to say that segment AB was congruent to CD, we would have to write it like this. So lengths are equal, the segments are congruent. They kind of mean the same thing. If 2 segments are congruent, they have the same length. There's a little bit more to congruency as we get later in geometry. Some of these diagrams that you have to draw, if J is between E and C, you might draw a line segment, start with E and C, and put J somewhere in the middle. You label the parts you know, and this is that segment addition postulate. 12 plus 7 equals the larger thing, which is just 19. So there's a couple different formulas there, depending on whether we're looking at just 2 segments or 2 segments that have a midpoint in the middle. With a midpoint, the 2 sides are equal. Here they are not. And there's a little bit of algebra involved, but that's about it for this section. So if 2 segments are congruent, and we know the measurement of one of them, the other one's going to be the same. It's also going to be 13. Or if they tell us that this part is 4.125, this little dash mark, this hash mark here, means that those 2 segments are congruent. That's a notation in geometry. So this one is 4.125. And to find GH, we would just add them together. So this one is a little bit longer, but it had the same concept where we were breaking things down by segments and adding up to make the whole. And then we could go back and figure out some of those in between. So let's go to the last section about measuring between coordinates. Now we're in the coordinate plane. So previously we were just looking at segments somewhere in space. And now we are looking at segments that exist on the coordinate plane. So we have x and y coordinates. Can we still measure them? Yes. And in some cases, it's pretty easy to measure them. For example, if our line segment is like this, straight across, we can just count how many marks we are over, and that tells us the distance. The same thing is true if we have a vertical line segment. We can simply count up. The challenge is when some of these segments are diagonal, because you cannot just count over. The units don't work that way. So there's a couple different strategies on how to count from one point to the other. And we're also dealing with how to find midpoints in this section. So let's start with the second one here. If we have these endpoints and we want to find the midpoint, all you have to do is add together your x coordinates and divide by 2. Add together your y coordinates and divide by 2. If you resolve that, you will get your midpoint. So here, this gives me 0 for my x coordinate, and this gives me 2 for my y coordinate. That's the midpoint. Oh, -2. The other possibility is when they don't give us the 2 endpoints, they give us one endpoint and one midpoint. So for example, we have L, M, and N. And if we were thinking about it like the coordinates from before, L is over here, M is in the middle, N is on the right. They tell us L is -3, -1. They tell us M is 0, 1. We added 3 for our x coordinate. we're going to add 3 again. We added 2 for our y coordinate. We're going to add 2 again. We're going to follow that pattern. So n is going to be 3, 3. That's how you find the other coordinate, when you know one of them and the midpoint. You pay attention to what you added or subtracted to the x coordinates, and you repeat that pattern. Next, we get into the distance formula or the Pythagorean theorem. So there's a couple different diagrams like this, and we're trying to figure out if they're congruent. Let's do this one for the Pythagorean theorem. It says that a squared plus b squared is equal to c squared. And c is always the hypotenuse, which is across from the 90-degree angle. So c here is x, and then a and b, it doesn't matter if they're 6 or 8. You can mix them up. So what we're saying here is that 6 squared plus 8 squared is equal to c squared. Have you done this before, probably? 36 plus 64 is equal to c squared. 100 is equal to c squared. If I take the square root of both sides, I get 10 is equal to c, and guess what? That's my answer. That's the distance. And what we're measuring is the distance from here to here. And the strategy is to turn it into a right triangle and use those legs to help us find the hypotenuse. Another way to do it is to use 2 coordinates and use something called the distance formula. This is helpful when you don't have a triangle or when you don't have the graph to create the triangle. So all we have here are 2 coordinates, -5, 1, and 3, 5. So in general, the distance formula looks like this. We take the square root of x2 minus x1 squared plus y2 minus y1 squared, and we plug in those answers. So my x coordinates, it's going to be 3 minus a -5. So that's going to become the square root of 8 squared. And if I subtract my y coordinates, I'm going to have 5 minus 1. So this is going to give me 4 squared. So in other words, the square root of 64 plus 16, or the square root of 80. To find the answer here, I would put that in my calculator and round to the nearest tenth. I think that's about it.